Augmented reality (AR) is an interactive experience of a real-world environment where the objects that reside in the real world are enhanced by computer-generated perceptual information, sometimes across multiple sensory modalities, including visual, auditory, haptic, somatosensory, and olfactory. AR can be defined as a system that incorporates three basic features: a combination of real and virtual worlds, real-time interaction, and accurate The overlaid sensory information can be constructive, i.e. additive to the natural environment, or destructive, i.e. masking of the natural environment. This experience is seamlessly interwoven with the physical world such that it is perceived as an immersive aspect of the real environment. In this way, augmented reality alters one's ongoing perception of a real-world environment, whereas virtual reality completely replaces the user's real-world environment with a simulated one. Augmented reality is related to two largely synonymous terms: mixed reality and computer-mediated reality.
The essential worth of increased the truth is the way where segments of the advanced world mix into an individual's view of this present reality, not as a basic showcase of information, but rather through the mix of vivid sensations, which are seen as normal pieces of a climate. The soonest practical AR frameworks that gave vivid blended reality encounters to clients were concocted in the mid-1990s, beginning with the virtual Fixtures framework created at the U.S.
Aviation-based Armed Forces Armstrong Laboratory in 1992. Business increased reality encounters were first presented in amusement and gaming organizations. Hence, increased reality applications have traversed business ventures like training, interchanges, medication, and amusement. In schooling, substance might be gotten to by examining or review a picture with a cell phone or by utilizing markerless AR methods.
Augmented reality is used to enhance natural environments or situations and offer perceptually enriched experiences. With the help of advanced AR technologies, e.g. adding computer vision, incorporating AR cameras into smartphone applications and object recognition, the information about the surrounding real world of the user becomes interactive and digitally manipulated. Information about the environment and its objects is overlaid on the real world. This information can be virtual.
Augmented reality is any experience which is artificial and which adds to the already existing reality. Or real, e.g. seeing other real sensed or measured information such as electromagnetic radio waves overlaid in exact alignment with where they actually are in space. Augmented reality also has a lot of potential in the gathering and sharing of tacit knowledge. Augmentation techniques are typically performed in real time and in semantic contexts with environmental elements. Immersive perceptual information is sometimes combined with supplemental information like scores over a live video feed of a sporting event. This combines the benefits of both augmented reality technology and heads-up display technology. HUD Display. Different advancements are utilized in expanded reality delivering, including optical projection frameworks, screens, handheld gadgets, and show frameworks, which are worn on the human body. A head-mounted showcase (HMD) is a presentation gadget worn on the temple, for example, an outfit or cap mounted. HMDs place pictures of both the actual world and virtual articles over the client's field of view. Current HMDs frequently utilize sensors for 6 levels of opportunity checking that permit the framework to adjust virtual data to the actual world and change as needs be with the client's head developments. HMDs can give VR clients portable and cooperative encounters. Explicit suppliers, like Usense and Gestagon, incorporate signal controls for full virtual drenching.
Hardware components for augmented reality are a processor, display, sensors and input devices. Modern mobile computing devices like smartphones and tablet computers contain these elements, which often include a camera and microelectromechanical systems (MEMS), sensors such as an accelerometer, GPS, and solid-state compass, making them suitable AR platforms. There are 2 technologies used in augmented reality: diffractive waveguides and reflective waveguides.
Projection mapping augments real-world objects and scenes, without the use of special displays such as monitors, head-mounted displays or handheld devices. Projection mapping makes use of digital projectors to display graphical information onto physical objects. The key difference in projection mapping is that the display is separated from the users of the system. Since the displays are not associated with each user, projection mapping scales naturally up to groups of users, allowing for collocated collaboration between users.
Networking. Mobile augmented reality applications are gaining popularity because of the wide adoption of mobile and especially wearable devices. However, they often rely on computationally intensive computer vision algorithms with extreme latency requirements. To compensate for the lack of computing power, offloading data processing to a distant machine is often desired. Computation offloading introduces new constraints in applications, especially in terms of latency and bandwidth. Although there are a plethora of real-time multimedia transport protocols, there is a need for support from network infrastructure as well.
Urban design and planning. AR systems are being used as collaborative tools for design and planning in the built environment. For example, AR can be used to create augmented reality maps, buildings, and data feeds projected onto tabletops for collaborative viewing by built environment professionals. 109. Outdoor AR promises that designs and plans can be superimposed on the real world, redefining the remit of these professions to bring in situ design into their process. Design options can be articulated on-site, and appear closer to reality than traditional desktop mechanisms such as 2D maps and 3D models.
Networking mobile augmented reality applications are gaining popularity because of the wide adoption of mobile and especially wearable devices. However, they often rely on computationally intensive computer vision algorithms with extreme latency requirements. To compensate for the lack of computing power, offloading data processing to a distant machine is often desired. Computation offloading introduces new constraints in applications, especially in terms of latency and bandwidth. Although there are a plethora of real-time multimedia transport protocols, there is a need for support from network infrastructure as